Hola. We're going to keep going with complex numbers, and we're going to be looking at rational complex numbers where we have a complex number or an imaginary number in the denominator. And in order to get rid of them, you may have remembered from Algebra 1 and geometry the idea of a conjugate for simplifying radicals in the denominator. We're going to use that same process of multiplying by a complex conjugate. So first we have to figure out what a complex conjugate looks like, and then we have to figure out how to use it. So let's go. So a complex conjugate, there are two complex numbers that the terms are identical, but the signs between them are opposites. So the terms are identical terms, opposite signs between them. So I've kind of used color to set this apart. See how both complex numbers have a 3 as a constant and a 5i as an imaginary, but in the middle is one has a plus and one has a minus, okay? Again, in B, our constant is -2, our constant is -2, and then our imaginary is plus 3i and then minus 3i. So there's two ways of thinking about it. Same terms, different signs in between, or you could say same constant and then opposite imaginary numbers, okay? When complex conjugates are multiplied together, you always get a real number. It always simplifies to a real number. I'm going to do the first example, A, the long way, and then I'm going to show you how to do it the short way, all right? So let's try this. Eli's whining in the background. All right, so we learned how to multiply two complex numbers together, so let's do it. 3 times 3 is 9. 3 times -5 is 3 times -5i is -15i. 5i times +3 is plus 15i. And then -5i, positive 5i times -5i is -25i squared. Now we're going to combine our i's and substitute -1 for I squared. And we get 9. These cancel, and then we get minus 25 times -1, or we get 9 plus 25, which equals 34. Okay, now I want you to look at something. Here's a faster way to do it than doing it like that, all right? This is the thing behind the thing. What is 3 squared? 9. What is 5 squared? 25. And you add those two numbers together. It always works out. This, because I squared is a -1, this term always turns positive, and the middle terms always cancel. All right? So if I try the fast route on B, then I get -2 times -2, that is -2 squared is 4, and then plus 3 squared. So I get 4 plus 9 equals 13. Pretty fast that second way, isn't it? But you have to know what's going on in the background in order for that to work. So maybe replay that where you can see how I did it the long way, and then watch how I did it the short way. All right, I'm going to use the short way to work problems. So the first thing that we're going to do is we're going to state the complex conjugate. All right, then we're going to go back and I'm going to multiply them together. So let's just work on getting the complex conjugate. So the conjugate of 5i is -5i. The conjugate to 5 plus 7i is 5 minus 7i. The conjugate to -10 minus 3i, notice I'm not changing the first one, -10 plus 3i. Notice I don't change the sign of the negative 10, not of the constant, just of the sign in between, or you can think of it as the sign of the imaginary number. So now let's multiply this together. I get negative 25i squared, which becomes positive 25. Let's use our fast method. I get 5 times 5 is 25, plus 7 times 7 is 49. This only works when you have complex conjugates, and that is 1474. See how you always get a real number? Negative 10 times negative 10 is 100, and then 3 times 3 is 9, so it's always plus that, so I get 109. Okay? So here's what I want you to do. I want you to answer the video questions. There's going to be 3 of them, and I want you to first state the conjugates, and then second, you're going to find their product. Okay? Here we go. The conjugate of negative 3i is positive 3i. The conjugate of negative 8 plus 2i is negative 8 minus 2i. The conjugate of negative 2 minus 3i is negative 2 plus 3i. Okay, now I'm going to go back and I'm going to multiply them together. And this is, I just square my coefficients, and I get 9. I square my constant, the first term, that's going to be 64. I square the coefficient of my imaginary term, and that becomes plus 4, and I get 68. And on letter F, I get negative 2 squared is 4, and then 3 squared is plus 9, so I get 13. All right? Okay, we need this in order to simplify complex numbers from our denominator, so now you're ready to watch the next video.